Welcome. In this session, we will discuss and understand the concept of R square, F square, and Q square. We will also analyze, calculate, measure, interpret, and the concept of R square, F square, and Q square in Smart PLS3 practically. R square is also known as coefficient of determination, whereas F square is an effect size as well as Q square is predictive relevance. R square is a statistical measure that represents the proportion of the variance for a dependent variable that explained by an independent variable or variables in a regression model. Or in simple word, we can say that how much change occur in the endogenous variable, which is basically a dependent variable, due to exogenous variable, which is basically independent variable or more than one variable. So the concept of R square is that how much change can be accounted for in dependent variable due to one or more independent variables. There are some threshold limit of R square value. So if the value of R square is 0.25, which shows that there is a weak R square or coefficient of determination, whereas the value of R square up to 0.50, which shows there is a moderation coefficient of determination, whereas if the value of R square is higher than 0.75, which shows that there is a higher level of coefficient of determination within the model. Similarly, F square is the change in R square when an independent variable is removed from the model. The effect size is a measure of the magnitude of an effect that is independent of the size of the sample analyzed. We are also having a threshold limit of F square. If the value of F square is greater than equal to 0.02, which shows that there is a small F square effect, whereas if the value of F square is greater than equal to 0.15, which shows that there is moderation effect, and if the value of our F square is greater than or equal to 0.35, there might be a larger effect within the model. Similarly, we are also having a Q square. Q square or predictive relevance measure whether a research model has predictive relevancy or not. In other words, we can say that Q square is used to assess the predictive validity of a complex model as compared to other. If the value of Q square is greater than 0, we can say that the predictive relevance or Q square has been established in our research model. We need to follow some steps in order to analyze Q square, F square, and R square in Smart PLS3. At first, we are going to launch Smart PLS3 and develop our research model, the model that is having independent variables and dependent variable. So the next step is that go to calculate menu, select PLS algorithm and bootstrapping for analyzing R square and F square respectively. However, to measure Q square, we need to click on, or we need to perform blindfolding procedure to analyze and measure Q square. For practical demonstration, have a look. Sir, Smart PLS3. At first, we are going to develop our research model. For example, we are having 3 independent variable and 1 dependent variable. Add all independent variable and dependent variable into your research model. First IV, second IV, and final. our dependent variable, as well as we need to have one into more independent variable. Rename them. So, the, so, the, so, the, so, the, so these three are our independent variable, whereas the fourth one is our dependent variable. The first in, the first independent variable is knowledge exploitation. The second independent variable is team learning. However, the third independent variable is to analyze the impact of these three independent variable to our dependent variable, which is firm performance. Connect all the variables towards dependent variable to complete the model path that we are going to click on. In order to measure R square and F square, we need to click on calculate. Start calculation. If we can see the result menu, there is quality criteria and there is R square value. Just click into it, so we can see that the value of R square is 0.703. 0.703 stated that there is 70.3% impact of all these three independent variable towards the dependent variable. So the value of R square or coefficient determination is 70.3, and if we remember the threshold limit of R square, if the value is greater than 0.50, we can say that there is a moderating effect of R square. So this value is quite near to 0.75. So we can say that there is a higher level of impact of these three independent variable to dependent variable. Similarly, we also analyze beneath the R square value, there is the value of F square. So if we can see the value of F square, our first independent variable team learning shows that the value of F square is 0.492. So as we know that if the value of F square is greater than 0.35, there is larger effect size. So similarly, the second independent variable value shows that the value is 0.161. So if we remember the threshold limit of F square, which shows that if the value of F square is greater than 0.15, in our case it is 0.16, so the effect size is medium. Whereas if the value of effect size, which is F square, is greater than 0.02, which shows that there is a small level of effect size. So the value of knowledge exploitation in this case is 0.05, which is although greater than 0.02, however there is a smaller level of significance effect of knowledge exploitation. So this is how we are going to analyze R square and effect size by applying PLS algorithm. So the next step is that we are going to calculate bootstrapping. Click on bootstrapping, start calculation. So here we are. Under the quality criteria column, we need to click on R square. So if we can see that the result shows that there is positive and significance coefficient of determination, because the p value is less than 0.05, however the t value is greater than equal to 12. greater than equal to 1.96, so the value is greater than 1.96. So we are establishing coefficient of determination. So as we see that there is the variation that accounted in dependent variable due to independent variables are 70.3%. So which is from knowledge exploitation to 1.988, from team learning to 5.116, however through development to 2.9. So this coefficient of determination or R-square value is positively associated or have positively changed in our dependent variable, which is firm performance. So in order to measure predictive relevance or Q square, we need to go calculate blindfolding, start calculation. So here we are. So we are having a window of construct cross validated redundancy. So we need to have, in order to measure Q square, we perform construct cross validated redundancy in by applying blindfolding. So as we know that if the value of Q square is greater than 0, so we state that we have establishing a good predictive relevance or Q square. So in this case, if we can see our dependent variable, which is firm performance, and the value of Q square is 0.449. So basically 0.449 is greater than 0. So we can say that in this model we also establish predictive relevance or Q square. So we have learned how to perform R square, F square and Q square. So this model stated that we have established coefficient of determination, effect size and as well as predictive relevance. Thank you.